Alrighty, hey honors chemists, let's do a sample problem using the combined gas law. This combines multiple factors. So a sample of gas occupies 120 milliliters at 25 degrees Celsius and 1 atmosphere. That's initial. That's a lot. 120 milliliters, 25 degrees Celsius, which I'm just going to quickly put that into 298 Kelvin at 273, and 1 atmosphere. What is its volume? I'm looking for it. When the temperature is increased to 50 degrees Celsius, meaning this is 323 Kelvin, and the pressure is decreased to 0.7 atmospheres. Number of particles is constant. So I'm going to keep that constant. So I'll cross that out. So let's look at effects here. I'm going to kind of split this up. I like to look at, kind of split these boxes up. So temperature is increasing. And so for my volume, that's changing. If I increase the temperature, I should increase the volume. My pressure is decreasing. You should remember that pressure and volume are inversely proportional. So whatever I do to pressure, I do the opposite to volume. If I decrease my pressure, I should also increase my volume. So my volume is going to dramatically increase. Let's plug and chug using the combined gas law equation that we learned about. So we have P1V1 equals P2V2. P1V1 T1, P2V2 T2. Let's plug this all in. So my P1, my first pressure, T, V. My P1 is 1 atmosphere. My V1 is 120 milliliters. My T1 in Kelvin, which is good, is 298 Kelvin. My P2 is 0.7 atmospheres. My V2, I don't know. My T2 is 323 Kelvin. So let's plug and chug this into our combined gas law equation. This will be the toughest type of calculation that you'll have to do. You'll probably have one of these to do. So P1V1 over T1 equals P2V2 over T2. Let's plug and chug. 1 atmosphere, 120 milliliters. For right now, you won't have to worry about units because it will all add up. This will be our volume in milliliters. Since it's milliliters here, it'll be milliliters at the end. 298 Kelvin, P2, 0.7 atmospheres. V2, I don't know, over T2, which is 323 Kelvin. And so I like to just combine and do all the math on one side. So on this one side, I have 1 times 20, which is 120, divided by 298. So this left side becomes 0.403. This right side, I have 0.7 divided by 323, and that's multiplied times V2. I could just combine these two first. I could do 0.7 divided by 323. 0.7 divided by 323, and I get 0.00217 times V2. And then we could do this. This would look like in math class 0.043 equals 0.00217x. How would you solve for x? You would divide both sides by 0.00217. How would you solve for V2? You could treat V2 like x. Divide both sides by 0.0217. If I do this math, if I do 0.403 divided by 0.00217, I get 185.7 milliliters. Did my volume increase? Yes, it did. It went up a lot. That is how you answer using the combined gas law equation.